Hi everyone, my name is Louisa and I'm going to be doing an exercise in applying Ohm's law. And this is a little bit of a tricky example because it requires you to see some things about the circuit that are going to help you solve the problem, but I'm going to try my best to explain it to you. So here's our problem, and I wrote out the steps that I'm going to take to solve it. So we've got this circuit here that's got a 1 ohm resistor followed by a 3 and 4 ohm resistor in parallel with one another, and then that is in series with a 2 ohm resistor. And it's all over a battery of 5 volts, and they want us to find the voltage across each resistor. So the approach that I'm going to use to solve this problem is to find the current of the full circuit, which requires us to find the equivalent resistance of the entire circuit, and then use Ohm's law along with the voltage of the battery to find the total current. Then I'm going to use Ohm's law to find the voltages of the 1 ohm and 2 ohm resistors. And the reason that I can do that is because the 1 ohm and 2 ohm resistors are part of a large loop, the largest loop. Let me be specific. Because the 1 ohm and 2 ohm resistors must be passed through in every single possible pathway for current to travel, they will actually have the current of the circuit. So to clarify, the current in the 3 and 4 ohm resistors can vary. We're not exactly sure what it is yet because we haven't calculated it. However, the current in the 1 ohm and 2 ohm resistors is going to be the same as the current in the entire circuit because those two resistors are part of the completed circuit and they cannot be avoided. So I'm just going to quickly calculate the equivalent resistance for this circuit, and I'm going to skip explaining this because I've explained it in a couple of other videos, but I'll write my work on the slide. So I just found that the equivalent resistance is 33 over 7 ohms, and now I'm just going to plug that into Ohm's law to find the current. Remember that we're using a battery of 5 volts here, so we're going to have 5 is equal to the current times 33 over 7, and then we're just going to divide. Let me make sure we can tell that these are i's here. We're going to divide both sides by 33 over 7, and then our answer is we're going to have that the current is equal to 35 over 33 amperes. Now that we're looking at this simplified version of the circuit, it's a little bit easier to see why the 1 ohm and 2 ohm resistors are intrinsically part of the circuit. Now this resistor actually represents the potential pathways of going down the 3 or 4 ohm resistors in parallel, but the 1 ohm and 2 ohm resistors you will definitely have to go through, and because they are part of the most basic circuit, the current flowing through them is going to be I circuit, which is what we've calculated here, 35 over 33 amperes.